In this lesson, our objective is to be able to identify and use angle relationships. Congruent. Congruent means having the same measure. These are a pair of segments, segment MN and segment PQ. This shows that segment MN is 20 units long and segment PQ is 20 units long. How do we show that? MN equals 20 and PQ equals 20. So when they both equal the same length, we can show that their measures are equal. MN equals PQ. Notice we're not using a segment hat because we're discussing numbers and the length, the measure. When we use measure, we use equal signs. So equal is for using measure. And when the measure is the same, we note that these are congruent. So we say segment MN is congruent to segment PQ. Congruent has the symbol like an equal sign and then a squiggly hat. So you know that congruent means same measure because same means equal, and we see the equal sign in the congruent symbol. This is another way to show congruence. Instead of the number for the length, we're showing that segment WX has the same measure as segment YZ because they have hash marks that are of the same style. 3 hash marks in this segment, 3 hash marks in this segment. Therefore, we know that segment WX is congruent to segment YZ. We show the segment hat when we show the congruent symbol. So if an equal sign has a hat, so do our segments. This is a picture of two angles, and we see both angles measure 42 degrees. So we write that the measure of angle G equals the measure of angle S. Both of them are 42 degrees. Therefore, they are congruent. We can show another way of saying congruent without having the numerical degrees by showing an arc that is the same type of arc in both of the angles. Sometimes we put a hash mark through the arc as long as we match it to the one that it's congruent with. So we can write that angle G is congruent to angle S. Notice I take off the M because I'm not talking about the measure. Now I'm talking about how the angles are congruent. Adjacent angles. These are two angles that share a common vertex and side. They have no common interior points. So what does that mean to share a common vertex and side? Here are two angles, angles 1 and 2. I'm going to outline angle 1. These are the sides of angle 1 in blue. This is the interior of angle 1. Now I'm going to outline angle 2. These are the sides of angle 2. These are the interior points of angle 2. Notice that they have no common interior points. The interior points of angle 2 are not anywhere touching the interior points of angle 1. But what is touching is the common vertex and side. This is the common side. They both use that side. Think of also angles that are touching, like townhouses. Townhouses are houses that share a side. They're right next to each other. Then we have vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays. For example, ray ED is opposite from ray EC. Remember that opposite rays form a line. And then you have the opposite rays EB and EA. That forms this line. So another way to think of opposite rays is that we think of intersecting lines. When we have intersecting lines, we get vertical angles. Remember that the word vertical means up and down. Up and down is vertical, up and down. So if we look for angles that are vertical angles, they're going to be across from each other, up and down, such as this angle I'll show with an arc, and this angle I'll show with an arc. Angle AED is vertical to angles CEB, up and down from each other. Vertical angles are congruent, so this angle and this angle have the same measure. I've copied this figure to the right over here so that I can show you that no matter how we look at this picture, so on your paper you could turn your head, you could turn your paper. I'm going to turn the picture so that we see another pair of vertical angles. This angle is across from this angle, or up and down from each other, where the sides of the angles are still making these intersecting lines. So it doesn't really matter if we see them as up and down or left and right. If they're across from each other with intersecting lines, they're going to be vertical angles. So this angle is vertical from this angle. Notice I'm using a different type of angle mark, these arcs, to show that these are congruent, since vertical angles are congruent. Examples. In the diagram, angle 1 is adjacent to which angles? So let's trace the sides of angle 1. Here are the sides of angle 1. Which other angles share a side with angle 1? Angle 2. If I trace the sides, notice it shares a side and it shares the vertex. So angle 2 is adjacent to angle 1. But angle 1 has another side where there's another angle. Angle 4. If I trace the sides of angle 4, I see that it is also adjacent to angle 1, sharing a side and a vertex. Angle 4. Whoops, let's put that in the correct spot. Angle 4 is the other angle adjacent to angle 1. Number 2 asks, which angles in the figure are vertical angles? So remember, vertical angles means I have intersecting lines and I see them across from each other, whether it's across up and down or side to side. So where do I see intersecting lines in this picture that make angles? Starting here, I can trace the line all the way through to here, and starting here, I can trace this line all the way through to here. So using those two lines, I see angle 1 and angle 5 are across from each other. Therefore, angle 1 and angle 5 are vertical angles. I can put a hash mark to show that those are congruent angles since they are vertical angles. Number 3, two line segments intersect as shown. What is the value of x? So I see the line segments intersecting, which means that these angles that have degree measures are congruent. This angle is congruent to this angle because they are vertical angles. They are across from each other from intersecting line segments. So if they are the same measure, I can make an equation that shows that they are equal. 4x minus 5 equals 15. When I'm solving for x, I like it to be on the left. Now let's solve this equation. To get the x by itself, I add 5 to both sides. That leaves us with 4x equals 20. To get the x by itself, since 4 is multiplied to x, I divide both sides by 4. That leaves us with x equal to 5. So I know that x equals 5 is the value of x. Thanks for watching.